You want some help with trigonometry? I could probably help you. So trigonometry, we're just going to talk about right triangles because those are the only kinds of triangles that have these special properties that help us figure out information about them. First, let's talk about what to call these sides on a triangle, because that'll help us out. So you can see in the purple triangle that I just put this variable x in the upper corner, and in the blue triangle I put the x in the bottom. So let's name the other sides q and m. So where is that side m in relation to x? It's opposite it, right? So we can just call that the opposite side. That's easy. And then where's q? It's right next to x, so we can call that adjacent. That's a good word for it, right? So that'll help us remember. And we know the hypotenuse is directly across from the right angle. And in a notation, you have a little square that means 90 degrees, which is the right angle. So we know the hypotenuse. And then let's look at the blue triangle. So now that side q is opposite x. So we'll call that the opposite side. And then m is adjacent to x. So m is now the adjacent side. So that's just going to help us name some things. So now we have adjacent, opposite, and hypotenuse for both triangles, right? So now that we have those names, why does it matter? Well, we can set up some ratios that will help us figure out angle measures, because that's useful. So the main thing we need to know are sine, cosine, and tangent. That's just the name for these ratios. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So those are just different sides over each other. And a good way to remember that is so ka toa. You can just say that over again, so ka toa, and remember. Or you can remember some phrases like, some old hags can't always hide their old age. It's a good way to remember. It's just silly, but it'll help you remember. So now that you know that, let's go back and figure out how that'll help us figure out sides and angles. So in this purple triangle, we have one angle is 50 degrees. We have our right angle, 90. We know what that is already. And then this side is 5. Let's just call it 5. So we're trying to figure out the hypotenuse in this purple triangle. And we already have one side, which is the adjacent side, right? Because 5 here is adjacent to the angle we have, 50. So we can name that adjacent, if that'll help us. And we're trying to find hypotenuse. So what ratio relates adjacent to hypotenuse? Let's go back to so ka toa. Let's see, cosine is adjacent over hypotenuse. So let's use cosine for this problem. So we can say cosine of the angle we have, 50 degrees, equals adjacent over hypotenuse. And we have the adjacent side, so we can plug that in. So now we know cosine of 50 degrees equals 5 adjacent over hypotenuse. And we're trying to find hypotenuse, right? So we just cross multiply like we normally do. And we'll get hypotenuse equals 5 divided by the cosine of 50 degrees. Cool. Now we just plug that into our calculator because it's the only way to figure out the cosine. And make sure your calculator's in degree mode because we're plugging in a degree, right? 50 degrees. So that's important. And we get that the hypotenuse equals about 7.8. Cool. So we found one side using cosine. But what about if we want to find the other side? The opposite side. How do we figure that out? Well, we'll need another ratio, right? So what relates opposite to adjacent? Because we have that 5 again. Well, we go back to so ka toa. And let's see, tangent equals the opposite over adjacent. So let's use the tangent. So tangent, 50 degrees, equals opposite over adjacent, which is 5. So opposite over 5 equals tangent 50. Cool. Now we can just solve again to get the opposite side. And we get that the opposite equals 6. Cool. So now we can find the sides and the angles. So what about if we want to find the degree measure? It's a little bit different, but it's really the same ratios that we need. So let's say instead of having 50 degrees there, we don't know any of the angles, but we have two sides given. So now we have the adjacent side, which is 5, and we have the hypotenuse equals 10. Cool. So now we have two sides given and no angles. But we can still set up using a ratio. So what relates the adjacent to the hypotenuse? Again, SOHCAHTOA. So the cosine relates the adjacent to the hypotenuse. So it's the same kind of ratio. Cosine of x, because we don't know the degrees yet, equals adjacent over hypotenuse, which is 5 over 10. It's the numbers we have here. So now in our calculator, we use the inverse cosine because now we're trying to get the degree instead of the side. So now all we have to say is the inverse cosine of 5 over 10 equals x. And now we get that x equals 60 degrees.